That I show you how to do it. I don't know what I just did here. Okay, so from yesterday, we were talking about just beginning on vectors, right? And you were planning flights. So from city A here to city B here, we figured out, again, that's the flight we're going to take. It has a displacement because we're changing position from one to another. So that would be its magnitude. And it has a direction, which we said always measures from the north in this clockwise formation, right? So here we have a magnitude, that's the distance. Here we have a direction, which we call the azimuth, right? This was all kind of what we did yesterday. If the city is a little different arrangement, so we're going from city D to city F, then that would be this way. Still, magnitude is going to be the same, whatever that change of position, that distance is. But when we measure from the north, we have to go all the way around to here. Okay, that's the azimuth, right? So it's always measured from the north in that clockwise direction. All right. You're going to have some problems that have to deal with vectors today. The important part about the vector is when you have a vector, say like this, all right, let's say that's vector u, all right, and you want to take and maybe add to a vector, we have another vector here called v, then we have to make sure that on our paper we do not change the direction or the size of the vector. So if I have a vector u that looks like this, then on my paper I better make sure that that is the same size. I mean, I'm not going to measure it, but you know, it's got to be pretty much the same size, right? And in the same direction. So then I'm going to take this one, move it down to here, right? All right, that's vector v. Then once we add those vectors, tip to tail, that's how you add vectors, tip to tail. So what we mean by that is we have this here, vector this way, and then this one here. So we're going to go from tip to tail, tip, tail, tip, tail. Then that's going to form a resultant that would look like this. This is called the resultant vector. All right, that's how you add vectors. Okay, you're adding them like that. Always go tip to tail, draw on the resultant. Do not change them. So let's do another. Say we have a vector that's going at an azimuth of 30. So here's my vector, say about 30 degrees. Here's my north. All right, so I'm going to say this is about 30. All right, then I'm going to add another vector of that. Okay, and that vector is going to be at 120 degrees. So say I have a wind coming right here at 120. Okay, then I would draw this. Here's my resultant. Here's my tip to tail. Here's my resultant. My resultant always goes from the beginning to the end. This is what's going to happen. So if I have, I'm heading off in a 30-degree azimuth, and then I have a wind or something that's blowing at a 120-degree azimuth, then this would be my resultant. All right, so again here, so if we can actually put magnitudes on this, we could say maybe this is 50, right, units, and this is 10 units, then we would be able to figure out the resultant, right? So here we have 30 degrees here, right? I can transform the north, so I have 120 up here, right? So then I know that this is 60 left over, right? Hopefully you're kind of seeing that. So we got 120 here, okay? That leftover angle from this line here being drawn, that's going to be 60 degrees because it's 180 all the way there. This angle is 30 right here, which means this angle is 30 because we have parallel lines cut by a transversal, and those alternate interior angles are going to be the same. So if this angle is 30, this angle is 30, which means that in the whole thing, we have a nice 90-degree angle there. And that's an easy one. We can figure the resultant out because we got 50 degrees there, or excuse me, 50 units there, plus 10 units there. We're using Pythagorean theorem. Okay, so whatever the square root of 2600, that would be what the resultant's magnitude is. Okay. To find that direction, we wanted to find that angle, then again it's just a right triangle, so we could actually use sines and cosines to figure that out. So since it's a right triangle, we have this here, we need to use, I'm going to use sine. Okay, so sine of the angle, I don't know what that is equal to the opposite side, which is 10, over the hypotenuse, which is the square root of 2600. Let me just figure out what that is. .1 or 50.99, so we'll just make it 51, I guess. Okay, then I would just take the inverse of that, make sure that you are in the right setting. Okay, I don't know if I have inverse tangents. Let's see if we do. Oh, there we go. So here, let me clear this out. Okay, so I'm going to take inverse sine. Oh, doesn't like that. So I'm going to go 10 divided by 51. See what that is. Do an inverse sine on it, and it says it's 11 degrees. So, does that mean that's the answer? No, because remember that this part is what the 11.3 is. I need the azimuth measured all the way back to here. The good news is we know this angle here is 30, so we can just add and say that the azimuth of that is 41.3 degrees. Okay, so we have a magnitude of 51 units, whatever it was, right, and an azimuth of 41.3. Okay, but the key idea on these is that when you're adding vectors, you always add tip to tail. All right, always, and then the resultant goes like that. Okay, even if you have more vectors and you add them, oops, okay, your resultant is going to be wherever that vector ends up at. All right, that's how you add them. They talk about a scalar. So if we have a vector, say like this, vector u, and we wanted to talk about 3 u's, then that would simply be just taking these u's and adding them up. Okay, so here's 1 u, another u, and another u. So that would be 3 u's. All right, so that's how you would do a scalar. Right, you're just multiplying that vector's magnitude by 3, but you're keeping the direction the same. All right, and again, notice how this is pretty much the same length. So when you're drawing those kind of things, make sure that you keep your vectors at the same length and the same direction. Right? Maybe you could trace over the top of your packet with your paper so you're getting it right. So hopefully you kind of got that. Again, the important part is adding vectors and knowing that we're going to go tip to tail and that is the resultant. All right, and this was kind of messy, but you're just using, the ones you're going to use today are all right triangles. So you should be able to use Pythagorean theorem on that to get it. You should be very aware with your sines and cosines. You should be good at that, all right, at this point. And that's how you find those things, okay? So if you need to go back and review it, go back and review it. Otherwise, you're going to do warm-up number 2 and number 5. Okay, Ms. Knudsen has the page number for that. And then 1.1 through 1.6. All right. If you have any questions, the physics people are going to be really good at this stuff, so you got to rely on them as far as how we're drawing those out. All right. Otherwise, hopefully see you Monday, and have a good weekend.